Good morning, class 3, and welcome to Maths for today. We are continuing with our statistics, and we are going to be looking at discrete and continuous data today. So our learning objective for today is to know what discrete and continuous data is. So we have already covered a little bit of that. We've talked about the meaning of it, we've done the vocabulary of it, and you have talked a little bit about it last week, talking about discrete data and representing that in different ways. And we're actually going to be looking at the two together now. So we're moving into that continuous data and what that means. And we're going to understand how we can represent it visually, because depending on whether it's discrete or depending whether it's continuous, it can be represented in different ways, and there's different rules that we have to use when we're applying that. So success criteria 1, I can explain what discrete and continuous data is. So always doing that revision first, reminding ourselves of what the meaning of those words are so that we can use them really confidently using the mathematical language when we're explaining things. We're going to identify examples of discrete and continuous data. So although we've talked about it a lot already, we haven't really had a look at what the different examples are. You're going to have a go at sorting them out and putting them into their categories. You might even be able to come up with some of your own. And then we're going to be representing discrete and continuous data using bar graphs today, ensuring that we use the correct key features for each. Now, as we move through the week, we're going to be using different types of graphs for representing continuous data, because for different types of different continuous data, there's better ways of representing it than a bar graph. But today we're going to be using bar graphs. Okay, so we're going to start today. I've got a PowerPoint I'm going to show you. I will talk through each step that you need to do. You can pause it at any point that we need to, and then we will do an activity. So first of all, key language that you're going to need to know for today. So words that you need to be able to use confidently. So the word modal. So modal just means the piece of information that is the most common. So for example, if you remember last week when we were looking at data and we had the choices of a fruit that people had chosen in the shop, the piece of fruit that appeared the most was the modal. Okay, and that's going to be a word that we're using in today's lesson. Then we've got discrete data, continuous data, and variable. Now, discrete and continuous. Discrete, hopefully we know by now, describes a situation when each category is separate from each other. So we'd have examples of colours, chocolate bars, or shoe sizes. So the categories are separate. So even if I was doing things like types of pets, the individual one, cat is separate to dog, which is separate to rabbit, for example. There can be no continuation. They're all separate. Whereas continuous data describes the situation when you're using a quantity where the gaps in between always mean something. So anything you measure is continuous, like time or height. So when I mean there's gaps in between and they mean something, it means that, say, for example, if I said 10 to 11 o'clock and then 11 to 12 o'clock, 10 to 11, there's a gap in between there and it's got a value. Whereas the gap between a rabbit and a dog, there's no value in between that. Okay, they are completely separate, whereas time runs on from each other. And variable is the thing that can be changed in the data. For example, the favourite pets, the animal is the variable. Okay, so usually we're always going to be looking at a particular item or asking people a question, and the thing that we're collecting data about, whether it be the height of a plant or whether it be the type of vegetables we find in the shop, whatever it is, that's the data that we're collecting, that's the variable. Okay, so like the favourite pets, for example. So we've been through our learning objective and our success criteria for today. So the step 1 is for you to actually write the definitions of discrete and continuous data in your books. Okay, so you need to use what we've just done together, and but I would really like to see if you can write it in your own words. Can you recall that knowledge? So rather than going onto the PowerPoint and going back to the slide before, what I'd like you to do is challenge yourself. I'd like you to press pause, and I'd like you to write the word discrete data and write your own definition for what it is, and then write continuous data and write your own definition. Okay, we've used those words a lot, so hopefully now you should feel quite confident with explaining those in your book. So press pause, write it down, and then come back and we'll mark it together. So hopefully you've pressed pause and you've written your definitions, and you've come back now to the video to have a look if you're correct. So discrete data. Okay, describes the situation when each category is separate from the others, example, colours, chocolate bars or shoe sizes. So a really good way of knowing whether it's discrete data. Discrete data is counted. So I can count the number of people who liked rabbits, or the number of people who liked cats, for example. So I can count that data. Whereas continuous data describes a situation when you're using a quantity where the gap in between always means something. Anything you measure is continuous, like time or height. So continuous data is measured. So discrete data is counted. So that might be like the numbers of the numbers of pieces of pasta on each person's plate, for example, whereas continuous data is measured. So the amount of water in 4 different jugs, for example, that's going to be measured. So we're going to have a go at sourcing out. So this was our success criteria 2. Can we sort out the data sets into discrete or continuous data? So remembering that helpful hint from the last slide, is the data counted or measured? If it's counted, it's discrete. If it's measured, then it's continuous. So I've got the number of students in each class, people's height, answered the answers from a dice being rolled. I'm really sorry that says answered, it should say answers from the dice being rolled. So if I collected the information for each time I rolled a dice, how many 1s I got, how many 5s I got, and so on. Lengths of different leaves, weight of bags of sweets, number of sweets in a jar, the time it takes to run 100 meters. So what I'd like you to do is take a moment, again, pause my video, see if you can work out which one each one should be. Use that key question. Is it counted and therefore discrete, or is it measured and therefore it's continuous? So press pause, work it out, and then come back to me. So hopefully you've had a go at working out what each one is, and we're going to go through the answers together now. So we've got the number of students in each class. So if I was doing class 1 at school, I would count the number of children, class 2, count the and so on, and I might use tallies or pictograms or whatever to represent that, but I'm counting the number of pupils, and if the data is being counted, then it must be discrete. Sorry, writing on the screen is actually quite tricky. People's height. So I'm going to measure people. So I know that data that is measured is continuous. Oh, apologies. Answers from a dice being rolled. So again, if I'm rolling a dice and I'm collecting what the score was each time, I'm counting how many times I roll a 5, how many times I roll a 6. I'm counting it, and therefore it would be discrete. The length of leaves, length I'm measuring, so it's continuous. Weight of a bag of sweets, weight is measured, so again, I'm going to be continuous. The number of sweets in a jar, I'm going to count the number of sweets, so it must be discrete. And the time it takes to run 100 meters. Really sorry, I've just realized I've spelled discrete wrong. The time it takes to run 100 meters. So again, time is measured, so it's continuous. Apologize for my terrible spelling. So hopefully you'll be able to see that whether you've got them right or wrong, and know whether you're feeling confident and secure with knowing whether data is discrete or continuous. So again, remember those key questions I asked myself: is it being counted, is it being measured? And that told me if it was discrete or continuous. So what is a bar chart? So again, like I said to you before, we're representing discrete and continuous data as bar charts. So we always start with revision. What is a bar chart? You did this with Mrs. Chandler last week. So can you explain what a bar chart is? Can you list the features you must include when creating a bar chart? Is there any equipment you need to be able to create a bar chart? I'm sorry, again, I've missed a space in between 2 words. So you don't need to write answers to this, just in your head. Can you explain what it is? Can you list the features you might include when creating a bar chart? Is there any equipment you might need? Okay, so have a little think and then come back and join me. Okay, so a bar chart is a way of representing data, okay, and I can use it to represent lots of different types of data. And the reason it's called a bar chart is for very simple reasons, that each category is shown using a bar, using a column, and it usually has a thickness to it, and I can colour those in so I can show the different groupings, okay. Can we list the features that we must include when creating a bar chart? So I must have my x-axis and my y-axis, and they both Both must be labelled, whether it be types of pet, number of people, whatever it is, I have to label them. I've got to have a title to be able to tell what my graph is displaying. And then equipment that I need specifically for a bar chart here as well is I must have a ruler, because if I'm drawing my bar chart, I must use a ruler to draw it. Okay, so straight lines and lines using rulers when I'm representing that data is really, really important. You must make sure you're using a ruler to do your charts. So I've got two different sets of data here. I've got favorite color and I've got my heights here as well. Now you can see that they are both bar charts. So I've got my bars on each. However, when I am demonstrating discrete data and when I'm doing continuous data, there are different rules. So there's a lot of things that are the same. So both of them have a title. Okay, they're explaining what it is. Now, I tend to do a slightly longer title on my charts. So I might say a graph to show the heights of children in class 3, or a graph to show the favourite colour of people in East Grinstead, whatever it is. But it's got a title. Then I've labelled my y-axis. Now, remember, y is always up the stairs. And I've labelled my x-axis. Okay, but there are some differences. I've got my scale down the side here. Okay, I've got my scale, and your scale obviously depends on how many people you've asked or what your answers were, what your highest number of data was. Because if I've got 80 here, I wouldn't be counting in ones, because otherwise my line would be absolutely massive. So I'm using an appropriate scale to be able to do that. But the big difference is along this axis here. So in the discrete data, you can see that each section has a label in the middle of it, and there is a gap between each bar. Okay, so I must have a gap in between each one, and the label sits in the middle because each is its own category. Okay, whereas in this chart over here, okay, my labels sit on the edge of each bar, because this is showing me the number of people who measured between 1 meter and 1.2 meters. And you can see that there is no gap between my bar because height is continuous. So it's a bit like my ruler. I'm showing the number of people who on my ruler measured between 1 and 1.2. Well, my ruler then doesn't stop and restart. My ruler continues, and therefore my bars are next to each other. So discrete data has a gap. Continuous data has no gap. Discrete data, the label goes in the middle, and continuous data, the label goes on the edge. Okay, so key things to remember there. So discrete data, we put as I said, the small gap between the bars. The labels for the bars go in the middle underneath the bar. Continuous data, you must not leave a gap. The labels go under the tick marks at the beginning of each bar. So these are the tick marks here. This is what we call a tick mark. Okay. Now I've just written it out again there for you, because obviously my little scribblings on the board that we've just gone through together, if you want to refer back to this when you're doing your activity, I thought that might be quite confusing. So I've written it again here. This is the slide I would go back to if you want to double check yourself when it comes to doing your activity. So first of an example we've got here, I've got a type of pet and I've got the number of pets. So first question I'm going to ask myself is the data discrete or continuous? So what do you think? Have a little think. What do you think, discrete or continuous? Okay, so this data is discrete, okay, because it's being counted. If it was being measured, then it would be continuous, but it's being counted. It's the number of cats. Everything is separate, okay? There's no continuation of the measure, separate categories. So I've got my cat, my dog, my rabbit, my bird, my other. So it's discrete. So I need to think about how I'm going to present that in my bar chart. So my bar chart, it should have gaps between bars. And between bars, and the labels are in the middle. Oh, apologies, spelled that wrong. In the middle. So let's have a look. Am I right? Excellent. So can you see I've got my gaps in between my bars and my label goes in the middle of the bar? Okay, I've still got all of my other features. So I've still got my title, I've labeled my axis, and I've got my scale as well. So those key things, those key features have to be there every time, but depending if it's discrete or continuous depends on how I lay the bar chart out. So it's discrete, so I've got a gap and my labels go in the middle. So conversely here, I've got the number of people being measured at different heights. Okay, the different heights. So I've got 2 people between 1 meter and 1.2 meters, 8 people between 1.2 and 1.4, 15 people between 1.4 and 1.6, and 20 between 1.6 and 1.8, 5 between 1.8 and 2, and 1 between 2 and 2.2. So first question I'm going to ask myself, is it discrete or continuous? So hopefully you were saying to the computer screen, it is continuous data because it's being measured, which means there will be no gaps between the bars and the labels in the middle. Sorry. So the labels will be on the edge of each bar. So let's have a look and see if we're right. So here we go. I've got my bar chart. I've got no gaps in between my bars and my labels go on the edge of each bar here. Still got my X and Y axis measured, labeled. I've still got my scale down the side and I've still got my title. Okay, so certain key things that are always there, some there because it's continuous data. So what we're going to do now, just going to explain to you what the activity is. So you can see that on the web page, everything that I've just gone through on the PowerPoint is actually on the web page as well. So if you're not able to open the PowerPoint, it's not a problem. It's all on there anyway. So you can see it's all there. Then finally, task 3, have a go at the activity for today. And then I've got a little bit at the end that I'd like you to do as well to demonstrate your learning. But first of all, the activity. Now, you haven't got different sheets for today. Everybody's got the same one, okay? But it depends how far you will get through. So I only expect you to do the maths for as long as it takes you to do the session. So we obviously have an hour for the session. If you only get up to question 2, that's absolutely fine. If you're whizzing through, you can obviously keep going and go all the way to the end. So this will be seeing how far you get through the questions. So we've got a bar graph and we're asking certain questions about it. So we're asking those questions, is it discrete? Is it continuous? Reading the bar chart, how many students, how many more, how many altogether? Then we've got 2 questions here where you're going to be taking the data and turning it into a bar chart. So this one, I've provided one for you. These 2, you need to actually create the bar charts in your book. But before you do it, you need to decide if they are discrete or continuous. Okay, and then I've got a bar chart down the bottom here, and I want you to answer the questions about it. Now this one, it's got a question at the bottom, a do you agree question. So as you can see, as you get through the work, the questions are becoming gradually more challenging. So I would expect Red Chillies to be able to get all the way to the end here. And this final one, it means that you're going to have to really think about your answer. So we've got what do the why do the bars have gaps between them? Okay, and then do you agree that they should have gaps between them, or should they be touching? Do you agree that this is the way this data should have been represented? And your answer might be yes, and it might be no. Now, once you've done the activities, depending on how far you get, like I say, only go as far as you can go. Once you have done the activity, I do then have answers for you to be able to mark your work. So as you can see here, I'm not going to keep it up, but you can see that I've answered the questions, I've done some charts to show you, and then I've given you some answers, and you can see my answer is quite long. So you'll be able to mark your work at the end of it. Okay, please don't look at the answers until you've done the activity. The whole purpose is to challenge yourself. And then finally, like I said, on the lesson plan, there is a question at the end to demonstrate your understanding. So finally, can you complete these sentences to demonstrate your understanding? What is the difference between continuous and a discrete bar chart? How do you know when to use discrete or continuous bar graph to represent the data? So I've given you a sentence stem to use. The difference between a continuous and discrete bar graph is, and the independent variable is, whereas dependent variable is. Apologies, I'll change that in a second. It should say, I know when to use discrete and continuous because. So a couple of little tweaks for me to make on the webpage, I apologise, but you're going to have those sentence stems there to be able to help you. Let me know how you get on. Make sure you identify your success criteria in your work. And if you are having any trouble with discrete and continuous data, do email me and let me know. I'm more than happy to send through any extra bits that you need or any explanations if you're not sure, okay? So if you're not really understanding discrete and continuous data and what the different representations are in a bar graph, do let me know, okay? Because obviously in class, you would tell me if something wasn't quite right. We'd spend a little bit longer discussing it, whereas I can't see you. So I have to rely on you telling me if you're struggling with anything. So do get in contact if there is a problem. If not, then great work. And I look forward to seeing the photos of your work. I will see you in our next lesson.